On this page, we're actually going to do something called a composition of functions, which is where we do one function and then another function. I don't even really need to tell you that though. If you just follow the notation, you are going to do what it'll make sense, and you wouldn't even have to think of it as a separate topic as what we did on the first two pages. So in the first one, the way I would say this is f of g of 4. Now, just like anything else in math, we're going to start from the inner parentheses. So I'm going to find the value of g of 4. I'm going to kind of ignore the f for now, and we will come back to it. So I'm just starting from the inside. It's easiest to just write it by itself. So g of 4 is, we're using g of x, negative 4 plus 3. So g of 4 equals negative 1. So I'm going to take that answer. That's what goes right where that red circle is. So now we're going to find f of negative 1. So we did the g function with a 4, we got our answer, and now we're going to do the f function with a negative 1. So here, 2 times negative 1 squared minus 4 times negative 1 plus 7. And if I evaluate that, this is going to be 2 times positive 1. Negative 4 plus, or negative 4 times negative 1 is positive 4, and then plus 7. So f of negative 1 equals 13, and that's my final answer. Here's another one where we have to do those two steps, use one function, use the answer in the other function. This time we're starting out with the f function. So if I plug in a 0 now, with our knowledge of functions, I know the answer is going to be 7, right? This is like a y-intercept question. If I plug in 0, everything else goes away and it's 7. But I am going to show the work for that. So f of 0 is 2 times 0 squared minus 4 times 0 plus 7. Everything else goes away. And we just get that f of 0 equals 7. So now we're going to take our answer of 7 and plug it into the g function. So g of 7 is just negative x plus 3, so negative 7 plus 3 is negative 4. Both of those, plug in a number, just basically like two plugins, and we're going to get a number out at the end. Now, certain functions get used in order a lot. And what we do in that situation is we create a new function that does the first function and then the second function. And that's what's going on in C and D. So if you don't really have to think about what's going on, as I said, if you read the notation, that's basically just what you do. So here I have my g function. I can't evaluate this. It's just f of x. So what that means is I'm actually plugging f of x into g of x. I'm going to write down what f of x is. So f of x is 2x squared minus 4x plus 7. And I'm going to plug that in, so directly in for the x in g of x. So that equals negative, plugging it into here. For x, I'm going to put in 2x squared minus 4x plus 7. And then the rest of g of x is plus 3. And then now we just look at it and see how we'll simplify. So we're going to distribute our negative. That should be a negative 4, so I'm making it positive 4. And then minus 7. So this is negative 2x squared. And I know this, we haven't maybe seen it exactly like this. When this becomes a positive, it's basically like it's just gone. Just like when we have the answer of 3, we don't write positive 3, it's just 3. Plus 4x, negative 7 plus 3 is negative 4. So this is our function, and this function would do f of x first and then g of x. The other composition we can do is in the opposite order, right? So if we plug g of x into f of x, so I'm going to take f of x, I'll actually just write it first. So this is f of g of x is negative x plus 3. So that's what we're plugging into f of x. That's going to look like 2 times negative x plus 3 squared minus 4 times negative x plus 3 plus 7. This is that one that does take a little longer to simplify. I'm just going to move this up a bit so we can do that. So I have to write the binomial twice to square it. When I distribute here, I get positive 4x minus 12 plus 7. And then from here, I'm going to do this part in my head. I get positive x squared, a negative 3x and a negative 3x from those two, so negative 6x, and then plus 9. I'm going to combine like terms and get negative 5. So this is 2x squared minus 12x plus 18 plus 4x minus 5. So 2x squared minus 8x plus 13 for my final answer. On this last page of the lesson, we're going to use those plugins and multiplying functions by things, adding things to functions, and we're kind of prepping for transformations because certain types of changes to functions do certain things to graphs, which is what we'll focus on tomorrow. So it says the following table includes two parent functions, simplest functions of a given type. So that's what a parent function is, and you'll see below. Complete each of the following function changes. You do not need to simplify. So we were simplifying on the other page. Here we're just going to change it and leave it. As I said, kind of heading more towards the transformations. So my cubic parent function, the simplest cubic function is here. My square root parent function, simplest square root function, is square root of x. So I have this written with f's over here. I'm going to write it with whatever letter is in the function. So this is g of x. So the first change we're doing is making x negative. So I'm going to write that with the g function. So g of negative x. That means that instead of x cubed, I'm going to get negative x cubed. I'm not even going to think about, simplifying. I'm just going to leave it, write it and leave it. So my next one is put a negative sign in the front. Now, actually, these two, and I should have written a G here. Sorry about that. The first two I just wrote will actually simplify to the same thing. That doesn't always happen. In certain types of functions it does, but as I said, we're just leaving them as they are. The next one would be g of x plus 2. That means plug in an x plus 2 for x. So right where the x is, I'm going to write x plus 2 and then cube it. No simplifying. The next one is a little different, right? So we have g of x and then we're subtracting 2. So that means I'm going to write my x cubed, my whole function, and then subtract the 2 and put it at the end. The next one is a combination of the two. So now we have put something in parentheses and also add something on the end. I think it's a little crowded, so I'm going to write it in a different color. So this is going to be x minus 2 in the parentheses and then tack the 5 on the end. Moving down the page, now we have multiplying by a function. So this is 3 times g of x. So that's 3 times x cubed. I can put it in parentheses. It's a monomial though, so it really doesn't make a difference. I wouldn't have to distribute if I was simplifying. The next one is putting a 1/2 in the front. So pretty much the same as the one above. As I said, parentheses you can do, but it doesn't really make a difference. And then moving down to the page to the last couple. This next one is both multiplying by 2 and plugging in the x plus 3. So we'll write it with g. So that's multiplying by 2 and we're plugging in x plus 3 and cubing it. Just to be safe, I'm going to put in an extra parentheses, but in this particular function, it would not make a difference. The next one is g of negative x minus 5. So I'm going to plug in negative x for x and then tack the minus 5 on the end. So I highly suggest that you try those same changes to the square root parent function. If you're watching this, if you're absent or for some other reason, you can watch me, but you will kind of want to get something down and then check it. So hopefully you've tried them. I'm going to do the same things with m of x a little faster. So this is m of negative x based on this function change. So that's the square root of negative x. This is negative m of x, which means I put the negative sign on the outside. This is m of x plus 2, which means the x plus 2 needs to get plugged right into where the square root is. This is m of x, and then minus 2 is going to get tacked on the end. So you have to be careful how you write this one. It's m of x is square root of x, and then outside of the radical is the minus 2. The next one is m of x minus 2 plus 5. So the x minus 2 goes in the radical, and the plus 5 goes after the radical. Here we have 3 m of x. So the 3 just gets tacked in the front of the square root. You can put these in parentheses. It doesn't really make a difference in terms of putting the square root in parentheses. And the last few, the next one is very similar. We have 1/2 m of x, which is 1/2 of the square root of x, 2 m of x plus 3. So the 2's in the front. And then we have the square root of x plus 3. And this, as I said, any of these I can put parentheses on. I'm just going to show you could put them. But basically the square root kind of holds everything inside of it in parentheses anyway. So it's just not necessary on those. The last one, we have m of negative x minus 5. So that's the square root of negative x and then minus 5 after the square root.